Now let's go to the ranges of elasticity. कितने टाइप की elasticities होती हैं? हम अभी तक बात कर रहे थे कि inelastic है, elastic है. Exactly what does this mean? How does the demand curve look like? Now we'll do all of that in detail. Okay, सबसे पहले अगर कोई elasticity zero है, क्या मतलब हुआ उसका? उसका मतलब हुआ elasticity अगर zero है, उसका मतलब हुआ percentage change in quantity upon percentage change in price is zero. तो मतलब अगर प्राइस 100% से भी इंक्रीज किया तो देयर इज नो रिस्पॉन्स टू चेंज इन क्वांटिटी. उसका क्या मतलब हुआ? उसका मतलब हुआ कि क्वांटिटी हो गई फिक्स. देयर इज नो चेंज इन क्वांटिटी, तो क्वांटिटी है फिक्स्ड. ओके, सो दिस इज द इलास्टिसिटी ऑफ जीरो. डिमांड कर्व व्हेन इज वर्टिकल इट शोज जीरो इलास्टिसिटी. Okay, no change in quantity for any change in price. Okay, so this vertical is in perfectly inelastic demand. What is this? This is perfectly inelastic demand, vertical. Got it? All right. So perfectly inelastic demand, vertical. Let's go to the next one. Any change in price, no change in demand. Okay. After perfectly inelastic demand, let's go to inelastic demand. So perfectly inelastic demand was elasticity of zero. Now this elasticity is between 0 and 1. When the elasticity lies between 0 and 1, it is called inelastic demand. Inelastic demand states elasticity is less than 1. Inelastic demand states that elasticity is less than 1. So elasticity is less than 1, more than 0. That is called inelastic demand. How does an inelastic demand curve look like? It is not vertical, but it is not very flat also. It is slightly steep. So a steep demand curve is inelastic. Let's see how. Initially, the price is 4 and quantity is 100. Then price increases to 5, but the quantity, so price increases by how much? From 4 to 5. It is an increase of 25%, correct? Because it's a change of 1. So the quantity fall will be less than 25%. The quantity fall is 10%. Okay. So in this case, the elasticity of demand is less than 1. That means the percentage change in quantity upon percentage change in price is less than 1, which means percentage change in quantity is less than the percentage change in price. Okay, so this is the meaning of inelastic demand. Inelastic demand means the percentage change in quantity is lesser than the percentage change in price. The demand curve is steeper and it is called inelastic demand. Inelastic demand, steep demand curve, percentage change in quantity is less than the percentage change in price. Price increases 25%, fall is only 10%. The next is unitary elastic demand. Unitary elastic demand is when elasticity is equal to 1, meaning both are the same. The percentage change in quantity. So in this case, we will have a sort of a rectangular hyperbola. So if the price is increasing by 25%, the quantity will also fall by 25%. So increase in price is 25%, fall in quantity is 25%. The elasticity of demand is equal to 1. It's called unitary elastic, right? Okay, next. Next is when you have elastic demand. Elastic is elasticity is more than 1. So in elastic demand, what will we have? The demand curve will be flat. Okay, if it is flatter, that means if the increase in price is 25%, elasticity is more than 1. So if increase in price is 25%, the fall in quantity demanded is going to be more than 25%. So here it is 50%. The increase in price is 25%, but the fall in quantity is 50%. So in terms of formula, percentage change in quantity by percentage change in price is more than 1. So percentage change in quantity is more than the percentage change in price. This is called elastic demand. Okay, so the percentage change in quantity is more than the percentage change in price. This is elastic demand, and elastic demand is flat. The demand curve looks flat. Okay. Next, perfectly elastic demand. Perfectly elastic demand means elasticity is equal to infinity. Okay, so at any price above 4, the quantity demanded is 0. At exactly 4, the consumers will demand any quantity. At a price below 4, the quantity demanded is infinite. This is the meaning of this is basically the definition of a horizontal demand curve. The horizontal demand curve has a perfectly elastic demand curve, which means that the price cannot be more than 4, the price will not be less than 4, it will only be 4. Okay. And at 4, the consumers can buy any quantity, this much also, this much also. So this means the percentage change in quantity upon the percentage change in price is equal to infinity. That means for any slight change in price, the response is infinite. Okay, any slight change in price, the response is infinite. So here what we show is that if price increases, the demand falls to 0. So at P is equal to 4, the demand is anything between 0 to infinity. Price less than 4, the demand is again infinity. So the change is very great. Okay, slight increase in price, the change is infinite. Okay, so this is the meaning of a perfectly elastic demand curve at which and that is usually a horizontal line. A perfectly elastic demand curve is a horizontal line with price fixed at the price. So if you see that the demand curves that we have been seeing thus far, their slopes change according to elasticity. So let's again revise. Perfectly inelastic demand curve, elastic demand curve, unitary elastic, elastic, perfectly elastic. Okay, so the steeper is the demand curve, the less the elasticity. So the steeper is the demand curve, the less the elasticity of demand. Okay, the flatter is the demand curve, the more is the elasticity. The steeper is the demand curve, less is the elasticity. All right, so we've already done this. Now moving on. So for example, elasticity of demand is 2. So it is more than 1. This is elastic demand. Elasticity of demand is 0.5. It is less than 1. It is inelastic demand. It is equal to 1. It is unitary elastic. Okay. All right, now let's go to another method of calculating elasticity. So what we've done till now was the mathematical method, right? Where we calculated elasticity between any 2 points. Now we also have this method through which we can calculate elasticity, which is called the point method of calculating elasticity. So at 1 point, how do you measure elasticity? Because in the earlier method, we needed 2 points. We could calculate elasticity between 2 points. Now here, there's only 1 point, let's say point C. You want to calculate elasticity at that point. So what's the formula for calculating elasticity at a particular point? So when you have 1 point to measure elasticity and you want to measure elasticity at that point, let's say that point is C. Now everything below that point is called the lower segment. Okay. Everything above that point is called the upper segment. Okay. C may or may not be the midpoint, so ignore this for now. When you have any point at which you want to calculate elasticity, anything below C is called the lower segment. Anything above C is called the upper segment. And by that, I mean the proper length of these 2 segments. Okay. So you can use a scale to measure the length of the 2 segments. Okay. All right, let me first do the formula. This is the formula. The point elasticity of demand is calculated by the length of the lower segment of the demand curve divided by the length of the upper segment of the demand curve. So any 1 point that you take, let's say you take this point. Okay, let's say we take point A. Okay, what is the elasticity? It is the length of the lower segment divided by the length of the upper segment. Okay, so length of the lower segment of the demand curve divided by the length of the upper segment of the demand curve, which pretty much means what we have here. Okay, when you are at the midpoint of the demand curve, the midpoint is when you are unitary elastic or elasticity is equal to 1. So at midpoint, you have elasticity equal to 1 because the length of the lower line segment is equal to the length of the upper line segment. Okay, so at the midpoint of a demand curve, the elasticity is equal to 1. Right? At the midpoint of the demand curve, the elasticity is equal to 1, which also means that at all the points which are below the midpoint, the elasticity is going to be less than 1. Why? Because the length of the lower segment is going to be lesser than the length of the upper segment. What is the formula for elasticity? The length of the lower segment divided by the length of the upper segment. So when you are in this region, the length of the lower segment will be smaller and the length of the upper segment will be larger. So elasticity is less than 1 in this segment. In this segment, on the other hand, if let's say you are at point A, the length of the lower segment will be more than the length of the upper segment. So the elasticity will be more than 1, and this point is called elastic demand. Okay. So on one single demand curve, the elasticity varies according to where you are. So if this is the midpoint, this is the elasticity is less than 1. This entire range is where elasticity is less than 1. It is inelastic. This entire range is where elasticity is more than 1 and it is elastic. Endpoints, of course, represent the ends also. At this point, the elasticity is 0 because the length of the lower segment is 0. And this is the point where elasticity is equal to infinity because the length of the upper segment is 0. Okay, so along a straight line, you have different elasticities along that demand curve, depending on where we are calculating the elasticity. Okay, so along one straight line, along one demand curve, we don't have one single elasticity. Okay, along one demand curve, we have different elasticities at different points. Okay, so along one demand curve, elasticity of demand varies. It is not constant. Okay, elasticity is equal to 1 at the midpoint. It is inelastic on the lower segments. It is elastic on the upper segments, inelastic in the lower segments, and these are the endpoints. All right. All right, now another way of calculating elasticity is the total revenue test. Okay, so whenever you, let's say, increase the price of a good, this is the total revenue method of calculating elasticity. Let's say you increase the price of a good. If you increase the price of a good, 3 things can happen. The total revenue that you earn. So let's say you were selling chairs. Okay, so you increase the price by 10%. What happens to your total revenue? If your revenue increases, then your good was inelastic. If your revenue stays the same, it's unitary elastic. If your total revenue falls, your good was elastic. So what happened? When price increased, if your total revenue falls, which means when price increased, people substituted it for something else. So elasticity was more. Okay. So if your good is elastic and you increase price, your revenue will fall. Okay. So if price changes, if the total revenue changes in the same direction, okay, the good is inelastic. So if price increases, total revenue increases, the good is inelastic. Or if price falls and the total revenue falls, then the good is inelastic. Okay, so when price changes, if the total revenue changes in the same direction, the good is inelastic. If price changes and the total revenue changes in the opposite direction, the demand is elastic. Okay, so if, let's say, price fell and total revenue actually rose, so your good was elastic. When price fell, people started buying more of a good, so your good was elastic. Okay, and the third is if total revenue does not change, then it is unitary elastic. So that is also a method of calculating. So in this, you don't need graphs, you don't need formulas. You just need to analyze your revenue. If you're changing price and the revenue is changing in the same direction, your good is inelastic. If you're changing price and the revenue is changing in the opposite direction, it is elastic. Okay, so this is another way of testing it. So we already know that along a demand curve, the lower side of the demand curve is inelastic. The upper side of the demand curve is elastic by the midpoint, by the point method, right? So this is corresponding to the total revenue curve. Okay, so the total revenue is highest at the midpoint. So what is happening here is that, let's say, as you move along from, let's say, point A to B, as price rises, total revenue rises initially. Okay, so initially, when price rises, total revenue rises. Okay, then it reaches its maximum. This is the midpoint. And after this, when price rises further, the total revenue is actually falling. Okay, so that's how you come to know then when the demand is inelastic, when price will rise, total revenue will rise. It's same direction. Okay, and if your price continues to rise, then if the total revenue falls, that means it's the opposite direction. When price has risen, total revenue is falling. Then you are in the range of elastic demand, which is this point. So above this point, if you keep increasing price further, you are in the range of elastic demand. In this case, total revenue falls. So total revenue is kind of moving along with the demand curve. Okay, so initially, as you increase price, total revenue rises. Then if you keep on increasing price, total revenue falls. And at the midpoint, total revenue is the maximum, right? So you may try to kind of be at this point at which your total revenue is maximum, which is also the midpoint of your demand curve. Okay, so so you can draw the total revenue curve to mirror the demand curve. Okay, so like the demand curve is inelastic in the lower segment, total revenue is rising in the lower segment. As your demand is elastic in the above segment, total revenue falls. Okay, so total revenue rises with price to a point, but then it declines. So as price increases, this part is where you have your demand curve as when price increases, TR increases, so demand is inelastic, and here it is elastic. All right, this is a grid. This is the total revenue test. So these are the 4 columns. If price increases and total revenue also increases, inelastic. If price decreases and total revenue increases, so opposite direction, that becomes elastic. Again, when price increases and total revenue falls, opposite reactions, that's elastic. When price decreases and total revenue falls, same sign, that's inelastic. So when price falls and total revenue also falls, that means when price fell, quantity increased, but not by a lot. So actually total revenue fell, right? So when price decreased, quantity increased, but not by a lot. So total revenue fell. So this means that the demand is inelastic. The increase in quantity is not going to be a lot. Okay, so this is the total revenue test for elasticity. So what we have to remember is that when price changes, in which direction is total revenue changes. On this, of course, from this we can understand what will happen to quantity, because ultimately we want to know how much by quantity change. So when price increases, the total revenue increases. That means the fall in quantity is not a lot, which would mean inelastic demand. So which is here. All right, so this is the total revenue test. All right, so to reiterate, price elasticity and total revenue, when elasticity is less than 1, which is typical of necessities, elasticity is more than 1, typical of luxuries, equal to 1 when there is no change in total revenue.